Okay, so I just have to start this again for the video for this. So we had said that you will have pH negative log to the base 10 of your hydrogen ion concentration, and the question I left you with was, how do we work out hydrogen ion concentration then? What's the formula you're supposed to remember?
Um, 10 to the power of minus the pH.
Yep. So they're the only two things that you will need for strong acids. So similarly for strong base, we just call it POH, negative log to the base 10 of your OH minus concentration, and pH is equal to 14 minus your POH. And that is really all they've ever asked on that. In your weak acid, we have two formulas. So we have the formula for pH, which is negative log to the base 10 square root of Ka by Ma. And then we have, say, for example, if we had to find Ka, what would we do? So this is the inverse log minus pH squared over Ma. In a weak base, we would have to find the POH. So that would be negative log to the base 10 Kb by Mb. And then pH is equal to 14, take away POH. And just if they decided to ask you for a Kb, it would be so that's squared again over Mb. So there are your equations. You need to be able to know them and to use them. Are we happy to move? So Izzy is saying yes. Alrighty, so the last part of this that we have to do has to do with the titrations, and they can ask this question at the end of a titration question, or they can ask it specifically in the acid base question. So we're looking at what they're called titration curves. So it would be if we had a pH meter and we started with our base or our acid and we're adding in drops of base, what would be the pH that we would be recording? So the first thing that we just have to do is recognize that they're weak acids. So that's why we only ever add the few drops in our titration, because they would be interfering with our pH. But there are little equations that will express what it is your indicator does. So if it's a weak acid, it's only slightly dissociated. So you usually would get colors involved. So we'll come to this in a second, but this might be red and this might be blue. And you would have colors. Now, you can also sometimes see it written as this. So instead of H indicator, they just use HX. And again, there will be colors involved in the question.
Are we writing?
Yeah, so do you see how you have a blank sentence up at the top?
Yeah.
Yeah, so that they're the two versions of the equation that they could possibly ask.
Okay. Thank you.
Now you need to know the pH range and the color change for the indicators that we've used, essentially. So I'm going to give you 3 indicators in the table. I don't know what you have written, but these are them. And when we do our titrations, this is our color change. So methyl orange, you should know by now, is orange to pink, and phenolphthalein is pink to colorless. But now we're giving you a pH range, and I'm going to explain what these mean in a little while. So these pH ranges dictate what titrations they're going to work on, whether it can work for strong acid, strong base. The other one we do is weak acid, strong base. So it's why do we choose the indicators that we do for it. So again, the arrow here is signifying the color change in the titration. So that's what we see in our flask.
And at the top where it says few, what does it say after few?
After few, up at the top, few drops. So we only ever put the few drops of indicator because they are weak acids and they themselves will neutralize some part of our base. Sorry, wrong mouse.
Miss, what do the arrows mean from like
So
orange to pink?
the orange, that's our color change. If they asked you in a titration, what's the color change with methyl orange, you would say orange to pink, because we put our base in the basement and the acid in the burette, and it is the first drop that will cause the color changes. Your neutral. So when we do methyl orange, it goes orange to pink. So that's what these arrows here mean. That's the color change we see in our titration. So you let me know a thumbs up now. I can see everyone but Chloe. Thank you, Izzy. Thank you, thank you, thank you. Okay, that is everybody. All right. So, can we remember what Le Chatelier's principle states?
When the system at equilibrium is subject to a stress,
Yeah.
the position of the equilibrium will shift to minimize the effect of it.
Yeah, so system at equilibrium is subjected to a stress. The system will change to, or the position of equilibrium will shift to minimize the effect of the stress. Juno has a beautiful way of saying it. She's so concise with her words, but I have to go the long way. So, position of equilibrium will shift to minimize the effect of the stress. Now, one thing that candidates do here is they forget that indicators can according to Le Chatelier. So if we have this scenario, so I've seen questions where people just have completely skipped the fact that they were asking about using Le Chatelier. So I've given you, it says state and explain the color change on addition of acid to the following scenario, and this is our scenario. And it's so if I add acid to this, which way is equilibrium going to shift and why? So scenario 1 is adding acid. Which way is equilibrium going to shift and why? What do we think? Any takers? You gotta write something in a paper.
To the right.
So where is the acid in this?
Oh no, the acid's on the right, is it?
Yeah, the acid is on the right. This is the acid. So if I add acid, which way is it going to go?
To the left.
It's going to go to the left. So in terms of our state is it's going to go red, and the reason is equilibrium will shift to the left-hand side to reduce the effect of increasing H plus concentration. So you have to recognize that acid is H plus. So the second scenario would be their most favorite one, and it's the one that goes over people's heads. So I'm going to flick forward unless somebody shakes their head at me. Nobody is shaking. So this is their second scenario. If I add base to this, what color is it going to go? And
Blue.
explain. So it's going to go blue. Can you explain to me why it goes blue?
Because acid is on the right. So it.
No, acid is on. Yeah, the acid is on the right. So if I'm adding base, I'm adding in OH minus. So that OH minus is going to go for this H plus. So it's going to go blue because it has to increase the H plus concentration. The OH is going to neutralize the H plus. So it's going to go blue because I now have to increase my H plus concentration. Is there any question on that?
You know, for when you're adding acid, when you add an acid, and in the equation the H plus is the acid.
Yep.
Is it the HIN that's the base?
No. So if we go back to the HIN would be the conjugate base. Remember when we did acid-base pairs? So yeah. But all they're looking for you to recognize is that from that equation you recognize that H plus here is acid. And if you're adding in base, then that base is going to neutralize that acid.
Okay. Thanks.
Okay?
But then when you add the acid, it does join onto the HIN on the left, or does it join onto IN minus?
It's so when you add the acid, you are adding acid to the right hand side. So that is this here. When you add acid, you're adding it in here. And one of the Chatelier's rules that says if you add it to one side, equilibrium shifts to the opposite. So that if you add acid, here is where you're adding it in. Okay, so when you add in base, it's going to neutralize the H plus. Equilibrium will shift to that side to increase the concentration of H plus. Now, I'm just going to show you this. So this is you